Okay, sorry for this short break, not short, really long break. So we'll go to the next session, which is, what is it? Managing diverse waste categories. Okay, so we have Mr. Suhas Dikshit and Mr. Crane and Professor Srinivas is a moderator.
Okay, good morning everyone. So after that nice introduction on MSW rules by Dr. Rakesh, SWM rules, we have a panel discussion on managing diverse waste categories. So there are two speakers with us, Mr. Suhas Dikshit from Agile Process Chemicals, he is the general manager, and Mr. Berthold Kren from Geocycle India, he is the India and Asia head in ACC. So they will be sharing their experiences in this domain of what are the waste streams they are trying to dispose and what are the technologies they are using. Please come on to the dance.
Am I audible? Yeah, okay. So let me start with a video. Video audio is connected, right? So rather than I telling you about the company, let the customer start telling our performance of our technology, and then I'll start the presentation.
Plastic litters this 180-acre dump site in Kenya's Kiambu County. The plastic helps workers like Lucy Wanjiro, a 35-year-old mother of 4 school-aged children, earn an income.
I come here to collect plastic with my friends. This job helps me pay for school fees, food, and everything.
Lucy and her colleagues collect about 12 tons of plastic a day from the site. A truck takes the day's bounty to Alternative Energy Systems Factory. Raj Kent, the founder of AESL, opened this facility in April 2017.
We are at Alternative Energy Systems Limited plant in Thika, where we are processing waste plastic into a synthetic oil.
Raj trained as an agriculturist and ran a successful food export company in Kenya for 18 years.
From there, I went to Uganda, where I met up with the Indian High Commissioner to Uganda, who introduced me to Indian technologies on waste treatment, and we decided to embark on a biodiesel project where in Dodoma, Tanzania. Whilst doing the proof of concept, it became abundantly clear that unless we are able to create a value source out of the waste, we would not succeed with the project. That led me to investigation of waste to energy technologies, bringing me, which is where I found this particular technology.
The process involves many steps to turn the plastic byproducts into their final form. The plastic first gets shredded, then it gets heated to remove the moisture. Once that's done, it's put into the feeder. From the feeding area, pistons push the material into the reactor. In the reactor, it goes through a process called thermocracking. Plastic is comprised of a series of long hydrocarbon chains, or commonly known as petrol. In the reactor, the long chains are turned into short ones. This ends up giving the synthetic oil the same properties as industrial diesel oil. For every 12 tons of plastic, AESL produces 7,000 liters of oil. Getting customers to understand the technology in Kenya was challenging at first for Raj.
However, our greatest challenge has been in the marketing of our synthetic oil, in that it's taken time for people to be convinced that our oil is a substitute for petroleum industrial diesel.
Primewire Steel, owned by its senior group of companies, is testing AESL's synthetic oil. They pay about 50 cents per liter for local petroleum oil, compared to AESL's rate of 75 cents per liter.
As a factory owner, I can let you know that using this oil, synthetic oil, is better than diesel because we do not have smoke. And here where our factory is located, it's around the place where there are many houses, factory buildings where people do not like to have smokes.
So that's our technologies plant in Kenya, which is operational. I was just adjusting the mic. I hope it works because the light doesn't show. So I would like to first of all start by thanking Professor Srinivas for giving the opportunity to be here and share our experiences with you. I would also like to thank Tata Center for making this event possible. And now I think I'm left with 10 minutes more to finish the rest of it. So the topic of presentation is challenges in pyrolysis or co-processing. Let us say, I think Prin would be talking about co-processing, right? So there are various technologies available for disposal of plastic waste, and there are challenges in doing that. So any guess what are the challenges in plastic recycling? We've got some young minds here. Let us see if they can be very straightforward to the subject. Post-consumer, let us say municipal solid waste segregated plastic. Mixed waste. Yeah, I mean, what happened is in between in Kenya, the plastic was banned. So the plant got some 300 tons of fresh plastic waste for shredding. The plant actually runs on the municipal solid waste segregated plastic waste. You can talk to the customer as well. I can give you the contact. If you want to visit Kenya, no problem. We can show you multiple plants around Mumbai as well. Yeah. No, but then we have plants operations. We'll show you nearby. Yeah. So that's exactly what we see it is, that it's dirty, and this is the exact challenge in recycling the plastic waste. It smells. So moment you try to take it in your facility, flies will come with it, and the smell will come with it. Then there is soil, which is ash most of the time. Then there is moisture. There is metal and stones, which create issues in the whatever technology that you use for processing. Whether you use pyrolysis or co-processing, I'm not sure how friendly is co-processing with large stones and metal, but then they would create products in the finished products, problems in the finished product. And then polymer content of this waste is less than 50%. This is one of the major problems. So when we say municipal solid waste segregated plastic waste, we cannot call it plastic waste because there is more than 50% is not plastic. So just because you see plastic, that doesn't mean that it is plastic. In case of municipal solid waste segregated plastic, what happens is that it is a laminated plastic. It has a large surface area. When a plastic has a large surface area, let us say weight of the carry bag is 5 grams and the surface area is like 2 square meters, then that 5 gram of carry bag can carry 10 grams of dust and moisture on its surface. So then you cannot call it a plastic just because you cannot see dust and moisture in that quantity. What you can see is plastic. So it is not plastic. So polymer content is less than 50%. So this is the real challenge that is there in the industry. No. Now, we as a company manage on some contract basis 550 metric tons of half of Navi Mumbai and Panvel. We are doing it by machines. Madam, you will appreciate a video that will come and you will see around 50 to 60 metric tons of plastic waste getting segregated every day, which entire say Mumbai's NGOs may not be able to do, because there is a limitation to a human capacity, what a rate at which machines can separate plastic waste. Once you see it, so that quantum is very high. At the same time, in case they have NGOs through your circle, in case we get NGOs that are able to give us profitable feedstock for pyrolysis, we would like to take it from them. So that actually depends on how much of moisture and dust is there in the plastic waste segregated by them. Yeah. So this is the actual plastic taken out of landfill site in Kenya. It's giving job to some 100 odd people there to separate this plastic waste from landfill site. We also get sometimes these electronic waste kind of things. So that also gets processed in the same plant. So all this, this was a stocking yard for the plant. So those buildings background has the plant, and all this is the plastic waste. Some 10 acres of plastic stocking area. Then all the plastic goes into the shredders. So we have two different shredders for shredding plastic films and the rigid plastics. Once the plastics are shredded, then it looks like this. So the screen is not very bright, but then I think you can see there is a lot of dirt and there is a lot of moisture in this. So what we need to do is, first of all, wash it. So the second stage is washing. Once the washing is done, then after washing it looks like this, but after washing then there is certain amount of moisture in it still. Then after that, this is good, thank you. So after this, once the plastic is washed like this, it still has around 30-40% of moisture. Then after that, it is dried in using sun drying like this. So in sun drying process, what happens is they lay down the plastic on open grounds like this, and the guy who is walking on that is just kicking around the plastic, just turning the plastic. Now this business is not that profitable that you can install automatic dryers. You can install a rotary tunnel dryer to make this happen, but then that would not make this, the rotary tunnel dryer installation itself will not make it economically viable, and the labor is quite cheap there, so we are able to use the labor and carry out drying in such manner. All this waste goes into the pyrolysis plants, and so it's all SCADA operated system. So this is my customer showing the plant to the ExxonMobil personnel. So ExxonMobil, we are discussing few things with them. So the whole plant is SCADA operated. Plant is operated from computer. All the temperature, pressure, all the data is recorded every 15 minutes, and Mumbai office monitors this project remotely. This is the quality of oil that is manufactured without using any catalyst right now. So without catalyst, we are able to manufacture this kind of oil. Now we are trying to seek expertise of Professor Srinivas. Is working, I believe, on the spent catalyst, use of spent catalyst in pyrolysis. So there are some other challenges in plastic pyrolysis where we are trying to work and identify opportunities to work together if possible. So other videos I will show quickly. So I'll start with the video of this 550 material that we do for city of Navi Mumbai on subcontract basis. So the waste is dumped into a auto feeder. Let me restart it. So the waste is, you can see the arrow, yeah. So waste is dumped in the auto feeder. So this box is the auto feeder. Then it goes into this machine, this vertical machine in which it falls into was a bag opener. All the carry bags are opened. Once the carry bags are opened, then this wet waste, dry waste segregator, this is a trommel. So we had to fit this in budget of municipal corporation. Earlier speaker talked about, Dr. Kumar, I guess, talked about municipal corporations not having money to pay salaries. So we had to fit in the budget of the body, you know. So we segregate the food waste. Once the food waste is segregated, if I can stop here. So it happens in an equipment called trommel. What you can, yeah, yeah. So it's trommels are quite used. I think it's used quite commonly in cement industry as well. Yeah, yeah. So yeah. So inside the box, inside this green box, what is there is what rightly pointed out by Srinivas sir. That there's a drum which has holes. So it is a rotating sieve. You feed the waste from one end, and then from sieves two things happen. Some of the waste falls down out of the holes, which tends to be biodegradable, most of it, and what doesn't fall out of that hole tends to be plastic most of the time. So we separate, what you see here is the stream of plastic coming out of that segregator, and this segregator, okay, I would like to pause here. First, let us talk about this. This is the biodegradable waste. As Dr. Kumar said that you cannot convert that into compost within 24 hours. So it's a process of 30 days. So all the waste is put in the windrows like this in this facility, and on these windrows we spray a sanitizer so it doesn't smell actually. So there are solutions available for odor as well. And then once it is converted into compost, there is a composting plant, which is a different video of another maybe 10 minutes. So in the composting plant, again, it's nothing special as such. There are rotating screens. You separate whatever is the residual plastic in this. You separate the plastic stones and all, and the less than 12-meter size city compost is getting sold to RCF, Rashtriya Chemical Fertilizers, at somewhere around 3.5 rupees per kg. We are able to give out around 50 to 60 metric tons of compost every day. Now, coming back to plastic, this plastic waste is segregated, and we are able to. This equipment is called air density segregator, and this plastic is thrown by air because it has a lighter density, so you can separate things using density as well. So you can see a live example here how plastic can be segregated. So we are able to segregate almost 40 to 60 tons of municipal solid waste segregated plastic every day out of around 550 metric tons of dump that comes from half of Navi Mumbai and Panvel. Now next videos I'll fast forward in between because it's again repetition of the pyrolysis that we are doing. So this is our, or I'll show you shorter videos. So this is the plant that is operational in Czech Republic. Now this is the plastic waste that is put into the feeding hopper. From the feeding hopper, it is conveyed using pneumatic conveyors to the feeding hopper at the top. So these are the pneumatic conveyors. Then from there it goes into the first reactor. There is one first level reactor here. There are two reactors below each other. So plastic basically enters into reactor and it is taken to temperatures of around 550 degrees Celsius. So the whole process is computer SCADA operated. This shows how the gas is getting utilized for using it as a fuel for the reactor. So byproduct of the process is around 15% gas, and the entire plant operates on the gas 24 hours, 7 days a week. We need to maintain it once in 15 days. So this is the quality of oil that is getting manufactured. This is one of our challenge, that what has happened is refineries have increased the standards of fuel to such a high level that in case we manufacture this kind of fuel, we can sell it in India and Africa. Selling this kind of fuel in Europe, it's not possible, you know. So we want to upgrade this quality of this fuel. We are working on a couple of ideas to do that, but unless you do hydro treating, you cannot get sulfur content below 50 ppm. And if you don't get sulfur content below 50 ppm, then it is not a Euro grade fuel. So it's kind of a monopoly created by refineries by raising the standards so high. And what they can do as well, but they don't do, is that you can use little high sulfur fuel in the industry. However, the emission that comes out can be scrubbed. There are pollution control technologies available, wherein you can do wet waste, dry waste, wet scrubbing, dry scrubbing, and I'm sure IIT would be more than capable in designing scrubbers. So scrubbers can be designed to accommodate fuels with little higher sulfur content, but that's not what is happening, because it's very difficult to change the standards there. So in Czech Republic plant, we are converting it into electricity. One liter of fuel gives around 2.5 to 3 units of electricity. That's what is happening there. So we sold it to somebody, he sold it to somebody else. Now the owner of the plant is a third person, but still going on. So sulfur becomes SOx, SO or SO2. So once you have SOx, to scrub it, you have wet scrubbers. Industrial fuel, yeah. All industries have, it is mandatory to have scrubbers. Indian Pollution Control Board doesn't give a permission for using a fuel in industries unless there is a scrubber installed, and they check if ETP as well is required or not. So in one of the problems with this plastic disposal is that plastic has challenges of high content of PET as well as a lot of metallized, like aluminum foil containing plastics also are there. So that's a multi-layer packaging waste. And new folder. So what I will do is, later time when I have extra time, I'll just transfer it and then I'll try to show it. So that was actually a video, or it's there on our website homepage, the first video on our website homepage. Our website is pyrolysisPlant.com. The name of the technology is pyrolysis plant. So you have internet operation? This is located at, thank you. This is located at Uflex Limited, Noida. We have put up a 6 ton per day multi-layer packaging waste disposal facility there. So all the packaging waste that comes, we are operating the plant right now. We will take over the operation. So all this multi-layer packaging waste that they need to destroy. Why they need to destroy is because sometimes the marketing strategy changes and then you have to dispose a lot of packaging material without entering it into market. This goes into market, people can manufacture duplicate products using the same packaging. So that's why they have to. So all this packaging enters into the reactor. This is the feeding system where you can see the plastic is falling down and it is getting pushed into the reactor. When it is getting pushed, then it is not falling, right? The piston comes back and more quantity will fall. Keep feeding the plastic into the reactor. the hot air generator, the gas produced is used. So the plant runs 24 hours on the gas. Additionally, we give out around 900 kilograms of gas every day to them minimum. And then in case they add more pet, then we are able to give them 2000 kilograms of gas every day. So that how much of gas is produced in the plant is a function of whether it's PET or polyethylene. This is the oil that is either gas is produced or oil is produced in more quantity. So we got some latest designs of machines installed and we never saw this quality of oil in our own plant. We are very happy with the development that recent development that our engineers have done. There is a control panel. So coming back to the gas, around say 2000 kg of gas per day in case we give, they have a multi-effect evaporator in which this gas is used as a fuel. They were earlier using around 2 tons of gas to evaporate 60,000 liters of water for their RO plant. And once we started giving out this gas to them, they started saving on 2000 kilograms of CNG every day, which is a direct saving of around 90,000 rupees per day for the company. So their waste is getting disposed. Duplicate products are not manufactured because waste is not leaking out to the environment, leaking out to the outside of the company, and they are making some revenue stream out of it as well. So this is the overall process. I don't know how much time do I have. 2 minutes. Okay. So let me figure out how to finish it off in 2 minutes. Yeah. So there is this plastic waste goes into the reactor using a airlock feeding mechanism. You cannot have air going into the reactor because molten plastic will catch fire. Then from reactor, the oil and gas vapor that is formed goes into the fractional condensation, basically condensation wherein the gas is separated and the oil is separated. So gas and wax goes back for high temperature combustion, or we can put it, the wax we can put it back into the reactor for pyrolysis. Ultimately what you get out of this is oil water. It goes to the oil water separator and we separate pyrolysis oil as well as we separate the wastewater. Wastewater goes into the ETP. So where does the wastewater come in from? The feed, plastic feed has moisture, and that moisture comes out as oily wastewater out of the plant. And then pyrolysis oil and this gas. So these are the two main products manufactured in Uflex Limited right now. So they are using these two products as a fuel. And then there is certain quantity of carbon generated. We are getting, in case of municipal solid waste segregated plastic, we get around 20-30% of carbon. If it is washed and dried, we get around 15-20% carbon. In case of packaging waste, like in the one you saw in the video, there we are getting only 5% carbon. So the need of R is basically washed and clean dry plastic waste. Then various technologies are available, and we as a small company are putting in some effort to make this plastic to fuel possible. Then long term and on paper cooperation from municipal corporation is necessary for investments to happen in this field. Lot of time municipal corporation start the cooperation, but then unless the cooperation is on paper for 5 years, then investor cannot secure the funds from the bank. So for washing and drying facility, this cooperation from municipal corporation is required to be on paper for at least period of 5 years till the time the investor pays the bank loan back, And if possible, segregation, cleaning and drying at source, which happens in Japan. So last slide should be, I guess, rather than trying to invent a wheel, this is already happening in Japan. There are no landfill sites there. All the plastic is washed, dried, and it is then used in various technologies. Right now, I believe whatever recycling can be done, it goes for recycling. certain quantity of it goes for co-processing. However, they have large quantities left now because now they cannot have export the waste. Basel Convention cannot allow the movement of plastic waste across the boundaries. So that cannot happen now. So that's it. This is our website. There is email address, and in case you don't get reply to the email, then that's the number. Thank you. Thank you.